Hello, my name is Kelvin DeCosta. Today's presentation, A Professional Guide to Structural Waterproofing, is a presentation designed to provide a broad brush overview of the principles and practices in line with the BS 8102-2009, the Code of Practice for the Protection of Structures from Water from the Ground. Established for over 40 years, Triton Systems, a UK family-run business, has been providing waterproofing solutions for both new and existing structures. We provide detailed drawings, specification guidance by CSSW qualified personnel, on-site installation guidance and training, as well as REBIT accredited CPDs. Our objectives is to provide an understanding of the principles of waterproofing design in accordance to BS 8102, to give an explanation of the different grades and the different types of waterproofing systems that can be used, to improve our knowledge on how to go about waterproofing a below ground structure, and to gain some insight into the importance of site practices. And also, we'll also provide some project references as case in point examples. So what's this waterproofing thing all about? Well, BS 8102-2009 and the dealing and how we go about water, it all starts with water. Normally arises in the form of rain. The rain percolates through the ground and eventually ends up at the water table, which can be well below the structure. It can be midway up the side of the structure, or it could be to full head height. Sometimes, depending on the type of ground that the water is having to pass through, it can get trapped and to form what we call perch water. Whatever the scenario, the code says that whatever system we bring to bear to waterproof that basement area, that system must be designed and installed in such a way as to provide protection to full head height. The reason for that is the water table level could suddenly rise unexpectedly, or there could be a water main burst, or some eventuality that causes water to appear to full head height of the structure. Either which way, your system has to be in place to resist that water entering the space you protected. Under the code, there are 3 grades of waterproofing. Grade 1 is a very basic grade. You'll see pooling of water, you'll see damp patches everywhere. It's fine for cars, but no good for us humans. Grade 2 is a little bit better. You'll see damp patches, you'll see vapor trails. A grade 2 would be typically a lift pit or a bin storage yard or a bike storage area, or a basic plant room would be considered the grade 2. Grade 3 would be this space, totally habitable, completely dry, carpets and fixtures and fittings everywhere. This is the sweet spot. This is what we're aiming for when we're setting about designing systems. Totally dry, habitable space. And the code states that there will be no water or moisture present in a grade 3 space. Here is an extract of Table 1 taken from the BS 8102-2009 code. And don't worry about the detail of the table for the moment, but just draw your attention to the arrows I've put on the display. The arrow on the left is an indication of the water table from high to low, from the bottom going up. And the arrow on the top from left to right is an indication of the types of systems and the level of risk as it reduces towards the right. And what we're trying to say there, what it's showing there is that within the code and the types of systems available to us, the combination of a type B and a type C system is the best fit solution to cover all scenarios of water table, whether it be low, medium, high or variable. There are 3 system types available to us in accordance to the code: type A, B and C. Type A systems are traditionally tanking systems, barriers. They live on the outside of the building, of the structure, and they're designed to be fully bonded to the structure. When water pressure is exerted on the membrane system, the membrane is actually pressed onto the structure to maximize the pressure of resistance to act as an effective barrier against water. Type B systems, this approach uses the structure itself as an integral part of the waterproofing strategy. In this case, concrete. If you're making the structure out of concrete anyway, why not make the risky below ground bits out of a watertight concrete? Type B systems, which we'll expand on a little bit later. And type C systems, these are internal cavity drain systems. These are systems that live on the internal face of the basement, and they manage water and take the water away from the space to be protected. So starting with type A's, barriers, or otherwise known as tanking systems, these come in many forms. The pictures on the top there show a sodium bentonite membrane on the left and a sticky back, peel back, traditional tanking membrane on the right. They can be applied, they can come in the form of cementitious renders, but bear in mind that a render is only as good or as bad as the people who are installing it. They are prone to inconsistencies of installation. So be mindful, consider carefully when you're deciding to use a cementitious render instead of a membrane. Type B systems, we modify the concrete, the ordinary concrete, turn that concrete into watertight concrete. Crystalline admixtures are recognized by far the best way of providing an integral system for Type Bs, because once installed within the concrete, they permanently remain within the concrete. And if during the building's life the building should crack and water tries to make its way through the crack, the water itself will cause the crack to self-heal using the crystalline process. Here's a case in point example of a situation where we have a crack in the concrete, typically 0.3, 0.4 millimeters. As water makes its way through the crack, the water itself causes the crystalline material to activate and cause that crack to self-heal in a relatively short period of time. And the material having repaired the crack, the material remains in the concrete for the duration of the building's life. Type C systems are water management systems. They're not designed to withstand high static pressure. They can be formed through using an isolating masonry wall or a platen cavity drain membrane system. They use pumps and sumps to gather the water and pump it away from the space. And they are the surefire way to achieve a grade 3 space of using a Type C system. And due to the nature of where they're installed, they can be easily accessible and they're maintainable. The components for a Type C system consists of a dimply looking membrane, which normally comes in the form of 8 millimeters for the wall and a 20 millimeter membrane for the floor. It's often referred to on site as egg crate due to its appearance. There's a whole host of components, additional extras you can buy for the system, depending on the nature of the area you're trying to protect. But they usually start off as a basic system consisting of 2 pumps, a primary and a secondary pump positioned within the sump. And then you can buy things like battery backup systems to provide ongoing power in the event that the main should fail. Or you have alarm systems so the users can be notified of any unusual water activity going on below their basement. When these systems are installed, they look like this. As the images below, you can see the membranes installed in the walls and the floor. At this point, you'd flood test the system to make sure the water is being collected correctly by the sumps and pumps before you install any walls and floor finishing works. The NHBC and similar insurance companies have additional requirements over and above that of BS 8102 2009. They invariably ask for a waterproofing specialist to be appointed at the beginning of a project to make sure that there's someone coordinating and looking after the waterproofing design, and to make sure that person is a certified surveyor in structural waterproofing, a CSSW accredited person. And they should be appointed as soon as possible within the design. They also ask for, in the case of grade 3 structures, they usually ask for 2 systems to be used. They've gone other days. Even though the code states you can achieve a grade 3 space with a single system, the insurance companies, the NHBC and other similar insurance companies, usually insist upon having a belt and brace or dual system approach when trying to achieve a grade 3 space. Site practice. Some of the site practices, if we look at the installation of a Type A system, it's pretty common sense really, but pretty simple really, but surfaces to be flat, make sure they're free of sharp projections, making sure that the membrane's not punctured before, during or after the installation by backfill. Make sure the area is free of standing water to make sure you get good bondings and good joint details between the layers and sections of membrane. Follow the minimum temperature guidelines. The contractors are usually under a lot of pressure to get these buildings built throughout the year. And in the spring and summer months, it's usually not a problem. But when you get towards the winter months, it's our experience that a lot of product membranes and materials used within the waterproofing industry are affected by cold weather, usually 5 degrees or less. Be mindful of those temperature thresholds in that they don't compromise the performance of the product you're trying to install. Type B systems, we want to make sure we're not adding additional water to watertight concrete. If we add water to watertight concrete, you'll cause it to crack, which again is contrary to our objective. Construction joints are absolutely key in a Type B situation. The construction joints are by far the area that has the common most failure. So attention to detail, attention to good quality workmanship is key to success. Curing is a factor that needs to be taken consider of, not only such an issue in the spring and summer months, but during the winter months when there's pressure to get projects built and completed in time. Contractors are often under pressure to take shutters down earlier than planned. Concrete, due to its nature, generates heat as it cures. If you take shutters away too soon in a cold environment, you're likely to cause thermal cracking, which again is a contrary to our objective. So just be mindful of the phases of works and when they're taking place to make sure that they're bearing the temperature differences in mind. Pour layouts again are key. Concrete hates being poured in long thin strips. If you pour it in long thin strips, you're encouraging it to crack. Concrete likes to be poured in nice big square sections. Square is the key. And this would be the ideal opportunity to get involved with your contractor to sit down and make sure that they have an input in their pour ratios to make sure they're planning to pour nice big square sections of concrete to reduce the risk of cracking occurring. And in general, just make sure that you adhere to good concrete code of best practice as detailed by the Concrete Society. That will generally lead to high levels of success with Type B systems. The watertight concrete's not handled any different. It doesn't taste any different, doesn't smell any different, doesn't set any slower or faster than ordinary concrete. It's treated and handled exactly the same way as conventional concrete. The difference is, when it's a watertight structure you're making, make sure you're crossing the T's and dotting the I's correctly to avoid cracking. Type C systems, detailing is key. Making sure that the water has a consistent, efficient means of getting to the sumps and pumps is essential to an effective Type C system. Making sure the surfaces are flat and there's no areas for water to pool, and make sure that the system can effectively remove the water quickly and effectively to the sump pump chambers. Lime treatments need to be applied to the concrete. If you're not using a crystalline-based concrete on your concrete walls, make sure you're using a line inhibitor. Otherwise, there's a significant risk of leaching agents coming out of the concrete over time and blocking up the channels and the pumps and sumps. And one of the key elements of a Type C system, and it's also a condition of most insurance companies, the system has to be maintained at least once a year to make sure the sumps and pumps are clear and the pumps all work and the channels are all clear if called upon. One of the projects, a lot of the new systems that we're seeing more and more of these days is ICF, insulated concrete formwork. Seeing a lot of these projects springing up now where they're using these systems below ground. It consists of two walls of polystyrene with a void, which can be infilled with the watertight concrete. Membranes can be applied to the outside face of the polystyrene system, and a Type C system, a conventional Type C system, can be installed on the inside face. So the choice of type systems of A, B, and C are still available to ICF type projects, and it can be reliably waterproof to grade 3 as a normal conventional build, concrete build. Type A membranes, making sure that they're installed correctly, making sure that there's no issues when you're installing the membrane. You get a good fully bonded system to the structure is key. The image there of the chap in the middle, he's installing a product of ours called Double Drain. It looks like a cavity drain system in reverse that's being applied to the outside of the building. The purpose of Double Drain is to ensure that when water arrives at the building, the water is deflected initially to a land drain. It's good practice, it's good waterproofing practice wherever possible to install a land drain. By installing a land drain around your structure, you take away a lot of the workload off of your chosen system or systems that you've got in place. The pressure is relieved to a large extent, and a lot of the water will be diverted around the building and harmlessly away from your structure, leaving your chosen system or systems to work, not have to work as hard, keeping the water out. A classic example of a Type B, we've got an example here of the Kia dealership in Brentford, where according to the code, a grade 2 structure was required, which can be easily achieved under the code by a single system. In this case, our TT mixed crystalline concrete was chosen throughout the build. Type C systems, again, very, very popular for both new build and existing build installations. They're They're good in that they're maintainable. You can get to them from the inside if you have to. And they're a surefire way to achieve a grade 3 structure by deploying a Type C system. But just remember that if you're not applying your Type C system to a crystalline-based concrete admixture system, a Type B system, remember to use your anti-lime agents on all concrete areas to avoid silting up of channels and pumps and sumps over time. And just remember, they're water management systems. They're not designed to withstand high static pressure. So in summary, we've explained some of the principles of waterproofing practice in accordance with the code, BS 8102/2009. We've explained some of the grades and the waterproofing types to be used within waterproofing structure. We've provided some guidance on how to waterproof a below ground structure and gain some insight into the importance of site practices. I hope you've enjoyed this presentation. Should you need more information or you'd like further advice or guidance with regards to structural waterproofing, please do contact us at sales@tritonsystems.co.uk. Thank you for watching. Goodbye.